Hello students, welcome to Brilliant Qatar NEET classes. All NEET aspirants are ready for this year NEET exam, which is going to be happen on 5th of May. I hope you know the exam pattern. NEET exam we have 180 questions and that should be completed in 180 minutes. So we are getting 1 minute to answer one question, and in that we have 45 questions from physics out of 50, 45 for chemistry out of 50, and 90 questions you have to attempt out of 100 for biology. So biology is covering more weightage, you know that, and biology will be a comparatively easy subject as far as NEET exam is concerned. Chemistry also it will be easy. Physics is your rank determining subject, my dear students, because you know that in physics more than 80% of the questions will be numerical type. So in these classes we would like to explain you how to crack, how to score maximum mark in physics. See, how much mark you are scoring in physics will be determining your rank, my dear students. So you know that in physics, once again, there are 45 questions. You'll be having total 50 questions. You have to attempt 45 questions from that. So how we can prepare for this? How we can crack maximum questions from this? We have 28 chapters. 28 chapters that physical world and all we can skip 28 chapters, and from this 28 chapters only they are going to ask 50 questions. That means average 2 questions per chapter. So how we can prepare? You know that physics, like the probability of asking numerically is very high. That means, my dear students, you have to be thorough with all mathematical equations and the exact physical meaning of each and every equation. That's the first thing. You have to study each and every formula and the meaning of each and every letter in that formula. Then you should be good in maths. That means your mathematical skill is going to be tested. How quickly you are going to do the calculations. I'm not talking about the tough calculations, the basic calculations, multiplication, division and all. You have to practice because there are some lengthy questions. So time management is also very important. So what is our plan is, like in coming classes we are going to explain you how to prepare for physics. For that, the first thing is, if you are checking the last previous year's NEET papers, you can see that the most of the questions are based on NCERT only. The concepts given in NCERT, the questions given in NCERT. So we have a plan, like we are going to explain you the each and every questions, that is called NCERT line by line questions. From each chapter we are going to discuss in coming sessions. So that's the first thing. So once that part is over, you have to practice the similar questions at home. Like at least try to cover 50 questions from a chapter. That do, like if you feel one question is a bit difficult, my dear students, at least 2-3 times you have to practice the same question. Then only you'll be able to do the questions based on the same concept. And after that, if you are writing a self-analyzing test by yourself, we'll be providing the questions. You just check your skill, check your analysis, like how much you can score from each chapter, and finally we will be having a mock test. Plenty of mock tests will be there. So through all these things you can easily crack the subject, you can easily score mark in physics, and you can get an MBBS seat very easily. So here we are going to start NCERT line by line from each and every chapter. Hello students. In this session, we are going to discuss NCERT line by line questions from the chapter Moving Charges and Magnetism, grade 12 physics. Let's move on to the first question. Current element delta L is equal to dxi cap, where dx is equal to 1 centimeter, is placed at the origin and carries a large current of 10 ampere. The magnetic field on y-axis at a distance 50 centimeter from it is. Magnetic field due to a small current element. So by seeing that itself, you got an idea it is based on which topic. It is from Biot-Savart's law. We have a direct formula in Biot-Savart's law to find magnetic field due to a small current carrying element. So before going into that formula, let's check what is the given situation. Current element dxi is placed at the origin. So where is that current element? It is at the origin of a coordinate system. The magnitude of field on y-axis. So current element is at the origin. We have to find field at a point on y-axis. So to understand it clearly, let's take a coordinate system. In this coordinate system, let it be the x-axis, and we can show the y-axis as well. This is the y-axis. Okay, now where is the current element? The current element is placed at the origin. So in this diagram you can clearly see that this is the origin. So current element is placed at the origin. What is that current element? It is delta L. It is equal to dx into I cap. I cap, you know the meaning of I cap. I cap means the direction of that element. Direction of current is along x-axis. So let us assume this is that current element. Okay, it is along x-axis. It is carrying current along x-axis. They are asking what is the field on y-axis at a distance of 50 centimeters. So let it be the point at a distance of 50 centimeter. Then what is the magnetic field at this point? Current is given as 10 ampere. You got a clear idea about the situation. Now let's recall the formula. What is it? If there is a small element, a small conductor carrying current I, and I'm taking a small element dl, and then that small element can produce a magnetic field at any point P, if this distance is r and if this angle is theta. Hope all of you remember the formula. What is it? dB. Why dB? Because it is field due to a small element only we are considering. So dB is equal to, what is the formula? It is mu naught by 4 pi. Mu naught by 4 pi I dl sine theta by r square. This is the expression for the magnetic field due to magnitude of magnetic field due to a small element carrying current. Now we can substitute the value. What is mu naught? Mu naught is 4 pi into 10 to the power minus 7. It's a constant, you know that, permeability of free space. The value is 4 pi into 10 power minus 7 divided by 4 pi. 4 pi will be cancelled. What is I? It is 10 ampere. 10 ampere. dl, length of the element, it is given 1 centimeter, my dear students. Please be careful about the unit. 1 centimeter, we need to convert into meter. That is 1 centimeter means 1 into 10 power minus 2 meter. 10 to the power minus 2 divided by 100, right? That's the meaning of multiply with 10 power minus 2 by r. Before that, sine theta. So this is, in this situation, you can see that in this particular question, what is the value of theta? You know, this theta is the angle between dl and r. dl is along x-axis, r is along y-axis. So what is the angle between those two? It is 90 degrees. Sine 90 is 1. So that term will become 1. Simple. R is equal to 50 centimeter. 50 centimeter. Half of a meter, right? So that's very simple to convert. Half meter. Half square. R square. Okay, now we can simplify this. 4 pi got cancelled. Look, 10 power minus 7 minus 2 will become minus 9. So 10 power minus 8 will come. 8 and 1 by 2 whole square is 1 by 4. That 4 will go up. So look at the result. 4 into 10 to the power minus 8 Tesla. That is the answer for this question. Very simple question. Just recall the formula and substituting. Don't make silly mistake. Be careful about the calculations. So what is our answer, my dear students? It is 4 into 10 to the power minus 8 Tesla. Okay, so I hope it is very clear. I am going to the next question, question number 2. Check this. Consider a tightly wound 100 turn coil of radius 12 centimeter carrying current of 10 ampere. What is the magnetic field at the center of this coil? Second application of Biot-Savart's law. What is it? Magnetic field due to a circular coil. Do you remember the formula? See, if you are taking a coil, a circular coil like this, it is carrying a current I. The radius of the coil, let it be A. And then what is the expression for the magnetic field at a distance R? We have a formula, that is B is equal to, what is it? B is equal to mu naught N I A square divided by 2 into A square plus R square whole raised to 3 by 2. This is the expression for the magnetic field to a circular coil. All of you know that. But in this case, what they are asking, what is the magnetic field at the center? So this is the expression for finding magnetic field at a distance r from the center, at a point on the axis at a distance r. But in this question, they are asking what is the field at the center. How can we find the field at the center? Field at the center means r value is equal to what? 0. R is equal to 0. So if you are substituting r is equal to 0, we'll get a simple formula. All of you know that B at the center, let's name it as B dash, it is equal to mu naught Ni by 2A. mu naught Ni by 2a. This is the expression for the magnetic field at the center of the circular coil, my dear students. Please keep this in your mind and let's check the value, the answer. What is mu naught? Again, it is 4 pi into 10 to the power minus 7 permeability of free space into a number of turns. How many turns are there? 100 turns are there. I, how many ampere? Current is 10 ampere. Okay, 10 ampere by 2 into, what is the radius? Radius is given as 12 centimeter. So 12 centimeter, 12 into 10 to the power minus 2. Now we can simplify this. 4 pi, 4 by 2 pi will come, 2 pi by 12 into 10 raised to minus 7 and 10, this 100 into 10 will become 1000. 10 raised to minus 7 into 1000 is 10 raised to minus 4 and this minus 2 will go up, it will become plus. So we get minus 4 and plus 2 will become 10 raised to minus 2. Minus 2. So we get pi by 6. Pi by 6 into what? 10 to the power minus 2. Pi by 6 means approximately 3 by 0.5 into 10 power 2. So it will be approximately 5.2 into 10 to the power minus 3. So by checking the option, you can no need to calculate, like you can do the mind calculation and you can approximate the result. You can see that the answer will be 5.2 into 10 power minus 3. But if options are very close, then you have to calculate. You have to calculate all the values properly. Here, without calculation itself, we can say the answer. What is it? It's option B, 5.2 into 10 to the power minus 3 Tesla. Clear or not? So, this question is based on magnetic field at the center of a circular coil. Okay, next question. Question number 3. Look at this. A straight wire carrying a current of 15 ampere is bent into a semicircular arc, semicircular, half of a circle of radius 2.5 centimeter. Then the magnetic field at the center of semicircular arc is. Semicircle means half of a circle. So we know the formula for the magnetic field to a complete circle. In the previous question only we used that. So this is semicircle means what will be the field formula? Half of the previous one. So magnetic field at the center of a circle is mu naught Ni by 2a. But what is N? How many turns? Is it one turn? No, it's only half. So N is half means what will be the formula? B due to a semicircle. B due to a semicircle will be mu naught I by 4a. This is the formula. Mu naught I by 4a. Now we can substitute the values. B is equal to mu naught. Once again, 4 pi into 10 to the power minus 7 into I. What is I value? 15 ampere. 15 ampere divided by 4 into radius. What is the radius? 2.5. Yes, 2.5. 4 and 4 got cancelled. 15 by 2.5 will be 6. So look at the result. It is 6 pi into 10 to the power minus 7. Pi is 3.14. So 16 to 3, 18. Yeah, again we can use an approximation. So the answer will be 18.8 into 10 to the power minus 5 Tesla. Which is the option? Option C is the right answer for this question. So circular at the center at any point on the axis. Now semicircular arc. Semicircle means half of this. Okay, right. Question number 4. Consider a tightly wound 200 turns coil of radius 10 centimeter carrying a current of 10 ampere. The magnitude of magnetic field at the center of the coil. Again, direct question. What is the magnetic field? The magnitude of the magnetic field at the center of a circular coil. So now without any doubt we can go to the equation. What is it? B is equal to mu naught Ni by 2a. This is the formula, you know that, mu naught Ni by 2a. Now we can substitute. Mu naught is 4 pi into 10 to the power minus 7. How many turns are there? 200 turns are there. So 200 into, current is 10 ampere divided by 2 into, what is the radius? Radius is 10 centimeter. So we get 10 into 10 power minus 2, which is 10 power minus 1. Okay, right. Now we can simplify this. 2, 4 will become 2 pi. Yes. Here again one more 2 is there. So 2 will be cancelled out. So we get 4 pi. And what about the power of 10? 10 raised to minus 7, and this is 1000, 10 raised to minus 4. This will go up. So 4 pi into 10 to the power minus 3 Tesla. Yes. 4 pi into 10 to the power minus 3 Tesla. Which option? Option B. Option B is the right answer for this question. 4 pi into 10 to the power minus 3. So this question is also based on the topic magnetic field due to a circular coil. Keep the formulas in your mind, my dear students. Question number 5. A long straight wire of circular cross-section of radius 5 centimeter is carrying a steady current of 20 ampere. Uniformly distributed over its cross-section, the magnetic field induction at 2 centimeter from the axis of the wire. This question is, it's a bit confusing and very important. So you just listen carefully. What is the question? A long straight wire. So the question is to find the magnetic field due to a straight wire. Magnetic field due to a straight wire. See, using Ampere's circuital theorem, we have derived an equation for magnetic field due to a straight wire. If I is the current carrying by a straight wire, at a distance, at a perpendicular distance r from this conductor, we have an equation for the magnetic field B is equal to how much? It is mu naught I by 2 pi r. This is the expression for the magnitude of magnetic field due to a straight conductor. But the problem with this question is, in this formula, what you can see is this point is outside the conductor. There is a thin wire. The point that we are considering is outside the conductor. But look at this question. Radius of the conductor is 5. So it's a thick wire. 5 centimeter radius is there. And where is the point they're asking? We need to find the field at a distance of only 2 centimeter. Which means, my dear students, please note that the point where the magnetic field is to be determined is not outside the conductor. It is inside the conductor. Confusing question. So how to find the magnetic field inside? Okay, so let me explain its theory first, and after that we will come back to this question. So listen carefully, my dear students. You will understand, because there is chance of asking sub questions also based on this. So let us understand it carefully. There is a long straight wire of cross-section radius, circular cross-section of radius 5 centimeter. So let me show a diagram to understand this carefully. Look, I'm going to take a conductor, cross-sectional view of the conductor. So let me take 2 ends of the conductor. Yeah. So this is the length. All right. Yeah. This is our conductor. And it is given its radius, cross-sectional radius is 5 centimeters. So cross-sectional radius means, before that let me draw an axis for this conductor. Look at this. Let it be the axis through the middle. So which is that cross-sectional radius? This is a cross-sectional radius. That radius, let us take it as r. So r is the cross-sectional radius. Okay. So you can see the diagram clearly. R is a cross-sectional radius of this. And this one is carrying a current of 20 ampere. 20 ampere we can substitute later. Let us assume the current carrying by this conductor is I. So it is carrying a current I. What they're asking what is the magnetic field at a distance 2 centimeters. So let it be the point where the field is to be determined. Where is it? It's inside. Remember, in that question it is 5 centimeter and this is 2 centimeters. So let me take it as small letter r. So hope you understand the difference between capital R and small letter r. Capital R is the radius of the wire. Small r is the distance from the axis to the point where the field is to be determined. Idea is clear now? Now, how can we find the field at this point? See, first thing, it's like a straight conductor part. The concept that we need to use is Ampere's circuital theorem only. So here also we are going to use Ampere's circuital theorem. But to apply Ampere's circuital theorem, we should have an idea about the net current enclosed. So our first aim is to determine the current enclosed by this particular cross-sectional area. Okay, how do we find that? Look at this. What is the current through the wire? It's I. I current is flowing through the wire. And what is the area of that cross section? Like radius is r. If radius is r, you know that the cross sectional area will be pi r square. Pi r square. So I current is passing through an area of pi r square, and it is given that the current is uniformly distributed. So everywhere it is distributed in uniformly. which means if I current is passing through pi r square area, what will be the current through unit area? It will be I by pi r square. Yes or no? I by pi r square. So that's what I'm going to write here first. Current through unit area. Current through unit area is equal to how much? Total current is I, area of cross section is pi r square. So this is the current through unit area. Through unit area, how much current is flowing means it is I by pi r square. Our aim is, look at this, this is our point where the field is to be determined. Take the cross sectional area of those particular regions. So you can see this much of region is there. What is its area? It is pi r square, which r? Small letter r. Our aim is to get the current through that part. Current through that part. How? Current through unit area is I by pi r square, and then current through that part will be current through unit area into area of that part. So how can we do that? Therefore, current through that small region, I am taking it as I dash. How can I write? Current through unit area I by pi r square into what? Area of that small part. It is pi r square. So pi got cancelled. We get I into small r square by what? Capital R square. This is I dash. This is I dash. Now once you get I dash, how do we find the magnetic field at this point? It's easy. Now you can apply Ampere-Circuital theorem. Hope you remember Ampere-Circuital theorem. What is its formula? Ampere-Circuital theorem states that the line integral of magnetic field, so integral B dot dl is equal to mu naught times the net current enclosed by the path, by the Amperian loop. So here we need to find the field at this point, so you can construct an Amperian loop like this. So what is the shape of that Amperian loop? Circular. What is the radius of that Amperian loop? R. So you can take a small element on this loop, that is dl. So we can write B dot dl is B dl cos theta. So integral B dl cos theta, B dl cos theta is equal to mu naught times I net. Net current enclosed by the path means current through this area. It is already we calculated. It is I into R square by R square. Cos theta. What is theta value here? You can see dl is circular. Magnetic field will also be circular due to a straight conductor. Applying thumb rule, you can see it is also what? Circular. So the angle between dl and b will be 0. Cos 0 is 1. So we get integral b dl. B is same. So b will comes out of the integration. So b into integral dl into mu naught I small r square by capital R square. Small r square by capital R square. Okay, so b into what is integral dl? Integral dl means length. Okay, integral dl means we have to add all dl. Which length? The length of this circular loop. What is its radius? R. So length of the loop means it is a circumference, which is 2 pi r. So b into 2 pi r is equal to what? Mu naught I r square by capital R square. Now we can cancel 1 r from both sides. B is equal to, look at the result, mu naught I small r divided by 2 pi capital R square. This is the expression we can use for finding the field at a point inside. Mu naught I r by 2 pi R square. Okay, so once we get this formula, now we can check what are the data given here. Okay, so listen please. B is equal to mu naught by 2 pi. Mu naught is 4 pi into 10 to the power minus 7 divided by 2 pi is there into I. What is current, my dear students? Please check. Current given is 20 ampere. Okay, 20 into small r. Small letter r is given as 2 centimeters. So 2 into 10 power minus 2. 2 into 10 to the power minus 2 divided by capital R square. Capital R is 5. So 5 square is 25 into 10 to the power minus 4 will come because it's square. So minus 2 square will become minus 4. So we can cancel pi, we can cancel 2 and 2 will be cancelled. So we get 4 into 2, 8 by 25 and power will be 10 to the power minus 7 and this 0 will become minus 6 minus 8 and there is 10 to the power minus 4. So this will go up. We get 8 by 25 into 10 to the power 4 into 10 to the power minus 8. So 100 by 25 will be 4. It will be 32 into this is 4 and this is minus 8. So 2 I have taken for making it 100. So there will be only 2, minus 6 will come, 10 to the power minus 6. So we get 3.2. 1 second, is there any? Eight by 25 is there. So 4 into 20, 4 into 2, 8. And there is a 10 to minus 6 minus 8, and this will go up plus 4. So that 100 by 25 is 4, 4 and 8 is 32, so minus 6. Okay, 32 into 10 power minus 6. Such an option is not there, so we can write it as yes, 3.2 into 10 to the power, yeah, minus 5. Right, 3.2 into 10 to the power minus 5. Test light is option D. Option D, my dear students. This is the right answer. Okay, so I hope this is clear for you. Magnetic field at a point inside. Now let's go to question number 6. Question number 6. A long straight cylindrical wire carries a current I, and current is uniformly distributed across the cross section of a conductor. Figure show the plot of magnitude of magnetic field distance from the center of the wire. The correct graph is. You can clearly see that this question is based on the previous concept only. Magnetic field due to a wire with the distance from the center. So again, if you are looking that if this is the cross section of the wire with the distance from the center, if this is a center, we can take this as R. So as R increases, what will happen to the field? So let's go back. Here we have a formula, mu naught IR by 2 pi R square. So clearly you can see that if that R is equal to 0, what will be the field? Field will be 0, and mu naught I by 2 pi R square is a constant. So clearly we can say B is directly proportional to R. So when R is equal to 0, magnetic field is 0, which means you can start our graph from where? From the origin. And when R increases, B will also increase. That is directly proportional. What will be the shape of the graph? The graph will be a straight line. So graph will be a straight line with a positive slope starting from the origin. Okay, till where? Till the surface of the conductor. So now we have only these two choices valid. Okay, only these two choices will be valid because here it is not directly proportional. Now out of these two, which is the right answer? Okay, after this point, here you can say small r is equal to capital R. After that, how it is varying? After that means it's outside. Outside, what is the formula? B is equal to mu naught I by 2 pi R. That means outside point, the magnetic field is inversely proportional to R. Then the shape of the graph will be like this. So now you got an idea which is the right answer here. It is option D, because till the surface you can see it is directly proportional. The graph is a straight line, and after that it is inversely proportional. So option D is our right answer. So question number 5 and 6 are based on the same concept. It is magnetic field of a due to a straight conductor, inside point and outside point. All right. Question number 7. A closely wound solenoid 80 centimeter long has 5 layers of windings of 400 turns each. The diameter of solenoid is 1.8 centimeter. If it carries a current of 8 ampere, then the magnitude of magnetic field intensity inside the solenoid near its center. Direct question, my dear students. It is magnetic field due to a solenoid. Magnetic field inside a solenoid. All of us know the formula for that. What is it? B is equal to mu naught Ni. Here, the only thing you need to be careful about is N. About N. What is that N? Small letter N is number of turns per unit length. Total number of turns is represented by capital letter N. Number of turns per unit length is represented by small n. So that is the only part we need to be very careful. What is mu naught value? 4 pi into 10 to the power minus 7 into n. What is n? N is, we need to find total number of turns is 400 and the length of the solenoid is 80. So small n is equal to total number of turns by how much? By 80. But 80 centimeter, that should be converted into meter. So 80 into 10 raised to minus 2 means that minus 2 will go up, will become plus 2. So what we get, n is how much? 400. So 400 into what? 100. 10 square is 100 divided by 80. So how much we will get? 500. So n is equal to 500. Substitute 500 into I. What is I? I is given as 8 ampere. Okay. So look at the result. How much we will get? 4 into 5 into 8, 40. So 4 into 4 we get 16. So 16 pi into what? 10 raised to minus 7. So it will become 10 raised to minus 5. 16 pi into 10 raised to minus 5. So pi value we can substitute, but before that, one more point is there in this question. We need to note 5 layers. Actually, we did not consider that number of layers here. This is due to 1 layer. So 5 layers are there, means we need to multiply it with by 5. So total magnetic field, if you are calculating, you can see that B is equal to 16 into 5, 80 pi into what? 10 to the power minus 5. Okay, so that is 8 pi into 10 to the power minus 4. 8 is 8 into 3.14 will be around 25 point. Did we made any calculation mistake here? Let's check. 4 pi into 10 power minus 7, n is 500 into I is what? 8 ampere. So 4 into 4 will be 16. Okay, there will be only 10 raised to minus 4 only, right? Yeah. 10 raised to minus 4 only will come here. So this is also 10 to the power minus 4. So this will be, finally we get, this has to be minus 3. Okay, so this is minus 4 and this will be minus 3. So it will be 25.13 into 10 to the power minus 3 Tesla. Okay, this is the answer, which is option B. Option B. Okay. B is the right answer for this question. Okay, not confusing, easy, but only thing we need to take care is about n. N is the number of turns per unit length. Question number 8. A circular coil of 30 turns and radius 8 cm carries a current of 6 ampere. It is suspended in a uniform horizontal magnetic field of 1 Tesla. The field lines makes an angle of 60 degrees with the normal to the coil. The magnitude of counter torque that must be applied to prevent the coil from turning is. Magnitude of torque that must be applied to prevent the coil from turning. No need to worry. It is actually equal to the torque experienced by the coil only, because you know that when a current carrying coil is kept in a magnetic field, it experiences a torque. So when it experiences a torque, it starts rotating. So how can you prevent the movement? We need to apply an equal and opposite torque. So the magnitude of torque experienced by the coil will be equal to the magnitude of torque required to prevent the movement. So indirectly what they're asking, they could have asked what is the torque experienced by the coils, but the question is asking like this. Okay, anyway, the formula is for calculating torque. Tell me the formula, my dear students. Torque is equal to, what is it? NIAB sin theta. Torque acting on a current carrying loop. MB sin theta, which is NIAB sin theta. Directly we can substitute N, number of turns. What is the total number of turns? 30. I, current, 6 ampere. 6 ampere. Area directly not given, but radius is there. It's a circular coil, pi r square. So pi 3.14 into radius 8 centimeters. Squaring we get 64 into 10 to the power minus 4. Okay, magnetic field value. Magnetic field is 1 Tesla, 1 into. Okay, sin theta. So what is theta in this formula? What is theta? In NIAB sin theta, what is theta? You know that it is the angle between vector B and vector A. Vector B, direction of magnetic field. What is vector A? Vector A is area vector of the coil. And you know that the direction of area vector is perpendicular to the plane of the coil. Which means if this is the direction of magnetic field, then the area vector is this one. So area vector means it is, what's the direction of area vector? It is perpendicular to the normal to the plane of the coil. So this angle only given as theta. Look, theta is the angle make 60 degree with the normal. Normal means it is direction of area vector. So directly we can substitute. Theta is 60, so sine 60 is root 3 by 2. Read root 3 by 2. So 30 into 6 into, so calculations are there. You just do the calculation. The answer will be like, here we get 3.13 Newton meter, approximately 3.13 Newton meter will be the answer for this question. So calculation, you can check whether it is correct or not. So it is not the calculation you have to take care, it is a formula, the concepts, like what happens when a current carrying loop is kept in a magnetic field. It will experience a torque. Understood? Question number 9. In a chamber, a uniform magnetic field of 1.2 Tesla is maintained. An electron is shot into the field with a speed of 3.2 into 10 power 6 meter per second normal to the field. The radius of circular orbit in which it starts circular path is. It's given mass of the particle is 9.1 into 10 power minus 31 kilogram. By seeing the question itself, I think you got an idea. Based on which topic? When a charged particle moving through a magnetic field, it experiences a force. What is that force called? It is called the magnetic Lorentz force. So this is a question based on what? Magnetic Lorentz force. In magnetic Lorentz force, you know that there are different cases. So what is the formula for Lorentz force? First of all, F is equal to QVB sine theta. This is the expression for the Lorentz force. What is theta? Theta is the angle between vector v and vector b. That means the velocity of particle and the magnetic field. If theta is 0, we get sine 0. Sine 0 means 0, the force will be 0. That means the charge will move without any deviation. Second possibility is theta is 180 degree. It is moving in anti-parallel direction. In that case also, the force will be 0. Third one, the very important, if theta is equal to 90 degree. If theta is 90, we get sine 90. Sine 90, the force will be maximum. Sine 90 is 1. Force maximum, and what will be the result? It follows a circular path. What about if theta is between 0 and 90 degree? You know that it follows a helical path. All concepts are clear for you. So this question is based on the third case. That means when it enters perpendicular, it follows a circular path. What they are asking, the radius of the circular path. We have already derived the formula for the radius. If anybody have a confusion about that, what is the radius formula and all, just use your basic idea. Circular path means it need what? It needs centripetal force. What is the formula for centripetal force, my dear students? mv square by r, right? mv square by r. That centripetal force is provided by Lorentz force, which is QVB. Sin theta will not be there because theta is equal to 90 degree. So from this we can cancel 1 v. We will get a direct equation for the radius. What is it? It is mv by qb. mv by qb. So substituting, we get what is the mass? Mass is 9.1 into 10 to the power minus 31 kilogram. Velocity is given as 3.2 into 10 to the power 6 meter per second. Charge of electron, it is electron, so it is 1.6 into 10 to the power minus 19 into the magnetic field is 1.2 Tesla. 1.2 Tesla. You can solve the calculations, and finally you will get the answer as 15.16 micrometer. The answer will be in micrometer, 10 raised to minus 6. 10 raised to minus 6. 15.16 into 10 raised to minus 6 meter will be the answer. That can be written as micrometer. So the answer for the question is option A, 15.16 micrometer. Keep the formula in your mind. Radius of circular orbit is R is equal to mv by qb. Okay. Next, question number 10. Two moving coil galvanometers, M1 and M2. Have the following particulars. N1 is equal to number of turns. For first one, 30. Magnetic field is 0.25 Tesla. Area of the first galvanometer is 7.2 into 10 power minus 3 meter square. Resistance of the first galvanometer is 10 ohm. Number of turns for the second is 60. Magnetic field is 0.50. Area is 1.8 into 10 power minus 3. G is 5 ohm. The spring constant, actually not spring constant, you know that in moving coil we are using the torsion constant concept. They are identical. The ratio of their current sensitivity. Current sensitivity is an important topic in that. So first of all, it is from which topic? It is from moving coil galvanometer. Hope you remember the working of a moving coil galvanometer. In a moving coil galvanometer, we have a formula for the current. What is it? Current I is equal to K by NAB into 5. This is the equation for the current in a moving coil galvanometer. So what is K here? K is the constant, proportionality constant. That means a constant of torsion constant, spring constant, anything you can call. N is number of turns, A is the area, B is the magnetic field strength, and phi is the deflection produced. Now, what is the meaning of current sensitivity? Sensitivity. So here you can see that I am giving I current to the galvanometer and I am getting a deflection of phi. So for I current, we are getting phi deflection. For I current, phi deflection. Then what will be the deflection for 1 ampere current? 1 ampere current. That deflection only known as what? The current sensitivity. Deflection per unit current. That means current sensitivity is phi by I. So phi by I is current sensitivity, means you can see that it is equal to what? NAB by K. Phi by I will be NAB by K. This is a formula for current sensitivity. Now what they are asking, we are given two galvanometers, we need to find the ratio of their current sensitivity. That means this by this. But one more point, the constant, spring constant is same. That means K is same, leave it. We need to take the ratio of NAB only. That means ratio of current sensitivity of first galvanometer to the second galvanometer will be equal to N1 A1 B1 divided by N2 A2 B2. Substitute. What is N1 for the first coil? N1 is 30. What is A1? Area is 7.2 into 10 to the power minus 3. What is B1? Magnetic field is given as 0.50 Tesla, 0.50 divided by N2. For the second one, it is 60 into area, second area is how much? It is 1.8 into 10 to the power minus 3 into magnetic field for the second. What is how much it is, where it is given? Sorry, this B1 is 0.25. Yeah, B1 is 0.2 and B2 is 0.50. Okay, now we can cancel this and this will be cancelled. 30 by 60, 1 by 2. 7.2 by 1.4 by 1, because 72 by 18 is 4, right? 4 by 1. And this is 0.25 by 0.50, again 1 by 2. So to 4 by 4, it's equal to what? 1. 1 is to 1 is there. So actually this is a very simple question. By seeing the question for the first time, like you maybe think that, oh, there are a lot of data, it will be a complicated question. No, it is actually a very simple question. You need to just recall the idea of sensitivity, water sensitivity formula, then just substituting the given data. Okay, simple question. I hope it is very, very clear for you. Let's move to the next question, number 11. A toroid ring has an inner radius of 21 centimeter and outer radius of 23 centimeter, in which 4,400 turns of wire are wound. If the current in the wire is 10 ampere, then the magnetic field inside the core of the toroid is toroid. What is a toroid, my dear students? A toroid is an endless solenoid, we can say like that, right? Something like this. Such an arrangement is called what? A toroid. We have already proved that the field inside, and that means the center, the middle region, the field will be 0. Outer region also the field will be 0. The field exists only in what? The core. Okay, and what is the formula for the magnetic field due to a toroid? B is equal to, it is formula is exactly the same as the field due to a solenoid. Mu naught Ni. But what is N? N is the number of turns per unit length. So how can we find that one? That's the only confusing part of this question. This toroid has an inner radius of 21 centimeters. So this is 21. And outer radius as how much? It is given as 23. So surely from that idea we can easily understand the average radius will be the sum of these two divided by 2. That will be 21 plus 23 by 2, that is 22 centimeter. That means the average radius R can be taken as 22 centimeter. Alright, now the total number of turns is given, it is 4,400. Total number of turns is 4,400 and N only we need to determine. How can we find? Small n is equal to, you know that it is capital N divided by L, total number of turns by length. So it is 4,400 divided by length. What is the length? Length is from here to here, how much length is there? That is equal to 2 pi r only, isn't it? 2 pi r. So we get 4400 divided by 2 into pi into, what is r value? R is 22. So we get 22 into 10 to the power minus 2 because it is in centimeter. So 22, 44 become 2 will be cancelled out. So we get here 2 zeros are there, and this also will go up. So we get 10 raised to 4 divided by pi. Yes or no? 10 raised to 4 divided by pi. This is n value. Okay, now we can substitute here. B is equal to, what is B value? It is 4 pi into 10 to the power minus 7 into n is 10 raised to 4 divided by pi into what? I. What is I? 10 ampere. Pi got cancelled. So we get 4 into 10 to the power minus 2, because this is minus 7, minus 5, I mean 5 will become minus 2. So 4 into 10 to the power minus 2 Tesla is the answer for this question. Option B is the right answer. 4 into 10 power minus 2 Tesla. Easy question. Just be careful about how to take the radius, how to find the number of turns per unit length and all. Alright, okay. Next, question number 12. Two concentric circular coils X and Y of radius 20 cm and 25 cm respectively lie in the same vertical plane. Coil X has 40 turns and coil Y has 100 turns. If coil X and Y carries currents of 18 ampere each but in opposite sense, then the net magnetic field due to the coils at the center is. You can see many questions of these type in previous year board papers and for competitive exams also. We know the magnetic field formula due to a coil. At the center of the coil, especially, it is mu naught Ni by 2a. But here they are asking, if there are two coils, what is the magnetic field? If more than one coil comes, you know that there will be more than one magnetic field. And remember students, magnetic field is a vector quantity. So if they are asking find the total magnetic field, means clearly it will be the vector sum of fields produced by the given coil. So here two coils are there and they are concentric, the centers are same. So let me show the situation. There are two circular coils. So let it be the first one. And there is one more coil. Both of them are concentric. So the center is same for both the coils. Okay. So let it be the center. Okay. And we need to find the field at the center only. But before that, a coil X and Y are there. The radius of X is 20 and Y is 25. So X is smaller one. So I can name this as X and this as Y. Okay. Number of turns are given. Coil X is 40, Y is 100. Current is 18 amperes. So current is same. Please note that. The net magnetic field of the coils at their center. Current magnitude is same, but they are flowing in opposite sense. Opposite sense means if through X, if current is flowing in clockwise direction, through Y, the current is flowing in what? Anti-clockwise direction. So you know that if you are applying the right arm palm rule, if current is clockwise, the magnetic field will be inward. And if it is anti-clockwise, it will be outward. So you can see that the fields are acting in two exactly opposite direction. If two fields are acting in opposite direction, how can you find the resultant field? It is a vector sum, that means the bigger one minus smaller one. So the field, when you are calculating, we can write the total field B is equal to Bx minus By. I don't know Bx or By which is big. That is not a problem here, because if you are getting it as a negative number, skip that negative, because they are asking only what? The magnitude. So just take the difference. Let's check. Okay. Now Bx, what is the formula for magnetic field at the center? Mu naught Ni by 2a. Mu naught Ni by 2a. But remember students, N is different. So Nx, Ax, current is same. So I am keeping current as it is. Minus mu naught Ny, current is same again, by 2 into Ay. You can take the constants out. So it is mu naught I by 2 into what? Nx by Ax minus Ny by Ay. So substitute. Mu naught is 4 pi into 10 to the power minus 7 into, what is the current I? Current is given as 18 ampere. Divided by 2. Nx, number of turns in X, 40. By radius is 20 centimeters. So 20 into 10 power minus 2. So that 10 power 2 will be there in the numerator. Minus, for Y, how many turns? 100 turns are there. By the radius is 25. Again in 10 power 2 will come. So this we can simplify now. 18 by 2 will become 9. 9 into 4 is 36. So 36 pi into the 10 raised to 2 I am taking out. So 4 by 2 is 2 minus 100 by 25 is 4. So we get this as 36 pi into 10 to the power. So there is minus 7. I missed it out. 10 raised to minus 7 and 10 raised to 2 will become minus 5. 36 pi into 2 into 10 to the power minus 5. So 72 pi into 10 to the power minus 5. So we get 36 into 2, 72 pi into 10 to the power minus 5. So 72 into 3, 21. So the answer will be approximation technique we can use. 3.70 into 3 will be 210. So 22 point, yeah, it will be option D. 2.26 into 10 to the power minus 3 Tesla. No other close options. So without any doubt, you can mark this option. So this is the right one. 2.26 into 10 power minus 3. Check the calculation. Okay, you can check the calculation. I'm skipping the calculation part. Okay, so I'm going to the next question, number 13. A galvanometer has resistance of 60 ohm. It is converted into an ammeter by connecting a shunt resistance of 1.2 ohm. The range becomes simple question. Simple question. In this chapter, we have an important topic. Two topics are there related to galvanometer. What are they? One is galvanometer, conversion of galvanometer into an ammeter. Other is conversion of galvanometer into a voltmeter. How can you convert a galvanometer into an ammeter? By connecting a shunt resistance parallel to it, low resistance parallel to it. For voltmeter, we need to convert a high resistance in series. And for each of these, we have formula for the required resistances. In ammeter conversion, what is the formula for S, shunt resistance? We have S is equal to Ig into G by what? I minus Ig. This is the formula. Now, what is the question they're asking? The range becomes how many times? So, galvanometer has a range. Ammeter is also will have a range. So, how many times the range of the ammeter is how many times of the range of the galvanometer? So, let's substitute what is shunt resistance value. It is 1.2. So, 1.2 is equal to Ig we don't know, but G galvanometer, resistance is 60 by what? I minus Ig. So bring this I minus Ig here. So we get I minus Ig is equal to Ig into 60 by 1.2. That is I minus Ig is equal to 60 by 1.2 is 50. So 50 Ig. So I equal to what? 50 Ig plus Ig, that is 51 Ig. We got the answer. So how many times? The range becomes 51 times. 51. So which option? Option C is the right answer. Okay, easy question. There will be other numericals also based on the formula. So please keep this formula in your mind. S is equal to IgG by I minus Ig. Alright, next. Number 14. To convert a galvanometer into a voltmeter of large range, we connect a resistance with galvanometer. The resistance. Direct question. We already discussed. How can you convert a galvanometer to connecting high resistance in series? Okay, high resistance in series, that means D option is correct. Okay, simple question. Question number 15. Magnetic moment associated with an electron moving at a speed v in a circular orbit of radius r is magnetic moment of a revolving electron. Simple question. Look at this. Let it be the orbit, an electron orbit in an atom. So take the radius as r, moving with a velocity v, charge of electron E, mass of electron we can take V. Okay, see the options. Everything is in terms of E, V and R. What is the question? Magnetic moment of electron. What is the formula for magnetic moment, my dear students? Magnetic moment of a current carrying loop. That's a concept we are going to use here. It is NIA. So moment M is equal to how much? NIA. Okay, so N, leave it, it is 1 only because one electron is revolving here, right, through fixed orbit. I, what is I? I is Q by T. That means charge by. What is the time we will take? We need to take the time taken by an electron to complete one rotation, that is capital T. Into what? Area. Area is pi r square. We can replace A by pi r square. Pi r square. Okay, so this is the magnetic moment, but you can check the options. There is no t in the option, so we need to replace t. What is t? The time period. You know that time period is equal to distance by velocity, that is 2 pi r by v. Substitute. So we get m is equal to e by 2 pi r by v into what? Pi r square. Pi got cancelled, r got cancelled, this will go up. Look at this, EVR by 2. Simple. EVR by 2. Option B is the right answer. Magnetic moment of a revolving electron is how much? Look, it is EVR by 2. Clear? Question number 16. The horizontal component of Earth's magnetic field at a certain place is 3.2 into 10 raised to minus 5 Tesla, and the field is directed from south to north. A long straight conductor is carrying a current of 3 ampere. What is force per unit length experienced by it when it is placed on the horizontal table and the current is in wire is from west to east? Force acting on a current carrying wire, force per unit length, that we will discuss later. Force acting on a current carrying wire, you know that when a current carrying conductor is kept in a magnetic field, it experiences a force. And what is the formula for that force? Force on a current carrying conductor in a magnetic field, F is equal to what? IL cross B, or it is ILB sine theta. This is the formula, you know that. Force on a current carrying conductor, ILB sine theta. Now here let's check horizontal component of Earth's magnetic field. The magnetic field given in this question is the horizontal component of Earth's magnetic field, and its direction is given from south to north. So we can just mark our normal way of marking direction: north here, south here, west will be here, east will be here. So what is the direction of current through the, direction of magnetic field? It is from south to north. Direction of magnetic field is from south to north. So this is what the direction of magnetic field. Okay, it is south to north. Vector B is like that. Okay, now what is the direction? A long straight conductor is carrying current of 3 ampere. So it's a long wire, the current is 3 ampere. It's kept on a table and the current is flowing from west to east. So the current carrying conductor, I can place it like this, west to east. So this is the direction of I. Now from this one data is very clear, that is theta. In this formula you can see that it is ILB sine theta. What is theta? It's angle between length. Length means the current element and the magnetic field. So what is that value? Magnetic field is like this, the current is flowing this way, means theta is 90, sine 90 is 1. So the formula will become simple. F is equal to what? ILB. Now we can substitute. What is I? Current is 3 ampere. 3. Length. Please note that they are asking what is the force per unit length. Per unit length means what is the length? 1 meter. So 3 into 1 into magnetic field. What is the magnetic field given? 3.2 into 10 to the power minus 5. So we get 9.6 into 10 to the power minus 5. Okay. So, but the problem is, if you are checking the option, you can see there are 2 options with the same magnitude, 9.6 into 10 power minus 5, 9.6 into 10 power minus 5, which is correct. Now, direction. How? We can apply left-hand rule. Force on a current carrying conductor in a magnetic field can be determined by the left-hand rule. Look at my dear students, like, a magnetic field is in that way, the current is in this way. That means middle finger indicate current. Current is going in that direction. Is west to east, and the magnetic field is from south to north. It's this way, right? This way means if you are keeping, like, if you are thinking about a map which is kept horizontally on your table, this is the magnetic field direction, this is the direction of current. You can see the thumb, it is upward. That means the answer is 9.6 into 10 power minus 5 Newton per meter, and that is in which direction? Upward direction. So our answer is option A, 9.6 into 10 power minus 5 Newton per meter, directed upward. Okay, right. Let's move on to the next question now. Question number 17. 2 long straight parallel wires A and B carrying currents of 20 ampere and 10 ampere is same direction are separated by a distance of 5 centimeter. The force on 15 centimeter section of wire B is, again, an important question based on an important topic. What is that topic? Force between 2 parallel current carrying wires. If you are arranging 2 conductors parallelly, And if both of them are carrying current, we derive a formula for the force. That means surely there will be a force between these two conductors. So if this one is carrying current in upward direction, this one is also carrying current in upward direction, that means the currents are in the same direction. You know the result. If currents are in the same direction, the force is attractive. And if currents are in opposite direction, the force will be repulsive. Okay, see, if the first one is carrying a current I1 and the second one is carrying a current I2 and the distance of separation is R, what is the force formula? F is equal to mu naught I1 I2 by 2 pi R. 2 pi R. This is for force acting per unit length. But if length of a given wire is L, then the equation will become mu naught I1 I2 by 2 pi R into L. So it's a direct formula, all of you know. Now just substitute. What is mu naught? Mu naught is 4 pi into 10 to the power minus 7. Into I1. What is I1? Current through the first wire, that is 20 ampere. Current through the second wire, that is 10 ampere. Divided by 2 pi into, what is R? R is the distance between them. It is 5 centimeter, 5. And length is 15. So no need to convert because both are centimeters. So centimeter will be cancelled out. Now we can simplify this. What we get? Pi got cancelled. Okay, so 4 into 2, 20 by 2 will become 10. This will become 3. So 4 into 3 is there. Okay. So this is 10 into 10 to the power minus 5 will come. Okay. That is 12 into 10 to the power minus 5. So we get 1.2 into 10 to the power minus 4. Yes. It is option D, attractive. Why it is attractive? Because it is given the currents are in the same direction. So the answer is option D. Option D is the right answer for this question. Clear? Yes. Important topic, my dear students. Force between two parallel current carrying conductors. Let's move on to the next question, number 18. A cyclotron's oscillatory frequency is 10 megahertz. What should be the operating magnetic field for accelerating deuterons? Cyclotron. You know what is a cyclotron? Cyclotron is a particle accelerator. It works on the principle of Lorentz force only. When a charged particle in this experience a force. And what is the formula for cyclotron frequency? Frequency of revolution of electron. We have a direct formula for the cyclotron frequency, but as I told you before, if you are not able to recall that formula, just go back to Lorentz force concept, that is mv square by r. Centripetal force is provided by QVB, cancelled out. So we get V is equal to QBR by M. This is velocity. Now how to find time period? Time period is equal to distance by velocity. Distance is 2 pi R by V. So we get 2 pi R by velocity is QBR by M. So R got cancelled. M will go up. We get T is equal to how much? 2 pi M by QB. This is the expression for the time period of revolution of electron. T is equal to 2 pi M by QB. Okay. Then what about frequency? Frequency nu is equal to reciprocal of this QB by 2 pi M. QB by 2 pi M. Now in this question, so this is the same as the frequency of cyclotron frequency is having the same formula only, QB by 2 pi M. Okay. What they're asking here, what is the operating magnetic field? We need to find B. So B is equal to how much? B is equal to, how can you write? 2 pi M into nu divided by 2 pi M into nu divided by Q. This is a formula. 2 pi M into nu by Q. Now just substitute. B is equal to, we get 2 pi. 2 into 3.14 into M, mass. Mass of what? Mass of the particle. Which is the given particle? It's a deuteron. Deuteron. What is deuteron? It is 1H2. Deuterium, right? That means its charge is equal to that of charge of proton, but mass is double the mass of proton. So it is 2 times mass of proton. 1.67 into 10 to the power minus 27 kilogram is the mass of proton. Okay, into nu, frequency is 10 megahertz. 10 into mega is 10 raised to 6. So 10 into 10 raised to 6 will become 10 raised to 7 divided by charge. Charge of proton is 1.6 into 10 to the power minus 19. Minus 19. Okay, so You can do the calculations like 1.6, approximately 1.67 and 1.6 will be cancelled out. By solving it, you will get it as, the answer will be 1.32 Tesla. That is option D is our right answer. Option D is the right answer for the question, 1.32 Tesla. Okay, if instead of neutron, if proton is the question, means this 2 will not be there. That means the magnetic field will be half of this, so we'll be getting 0.66. If it is proton, it will be 0.66. If it is a neutron, it is doubled, so it is 1.32. Got it? Yes. So let's go to the next question, question number 19. Look at this. A charge Q is equal to 1.6 into 10 power minus 12 coulomb, moving with a speed of V meter per second, crosses electric field. Electric field is given, it is 6 into 10 power 4 volt per meter, and magnetic field B is equal to 1.2 Tesla. The electric field and magnetic fields are crossed, and velocity V is also perpendicular to both. If the charge particle crosses both fields undeflected, not the point, undeflected, the value of V is. Crossed electric and magnetic field, my dear students. Cross means the angle between them will be what? Perpendicular. So this is magnetic field like this, electric field like this. So if you are sending a charge particle in this field, it will be experiencing what? Both the forces. It will be experiencing an electric Lorentz force and magnetic Lorentz force. And if these two are equal, and there is a case like if they are oppositely directed, the net force will be 0. So net force is 0 means what is the condition? The condition is electric Lorentz force QE is equal to the magnetic Lorentz force what? QVB. QVB. Okay. Then they are asking what is V? V is equal to what? QE by QB. We have this topic called velocity selector. The charge moves undeflected means this is the condition. So E by V, that's it. What is E? E is 6 into 10 to the power 4 divided by magnetic field is 1.2 Tesla. So what is the answer? 5 into 10 to the power 4 meter per second. Simple question, my dear students. Charge moves undeflected means the electric force and magnetic field should get cancelled out. It has to be in opposite direction, equal and opposite. So you can equate like this. So we'll get the answer as option D. Got it? Question number 20. Look at this. A proton is moving with a speed of 2 into 10 raised to 5 meter per second, enters a uniform magnetic field B is equal to 1.5 Tesla. At the entry, the velocity vector makes an angle of 30 degree to the direction of the magnetic field. The pitch of helical path is described as nearly pitch. So there is a magnetic field. You can see there is a magnetic field like this. And the velocities make an angle 30 degree with the magnetic field. So this is the velocity vector V. This angle is given as what? 30 degree. This angle is 30 degree. So we have already discussed this case. If a charge particle is entering a magnetic field at an angle which lies between 0 and 90, the path followed by this particle will be a helical path. So it will be following like this. So they are asking what is the pitch of the helix. What is the meaning of pitch? So it is the distance covered, the horizontal distance covered when it makes one rotation, right? When it makes one rotation, what is the horizontal distance covered? So how can we find pitch here? If you know the time taken to make one complete rotation, that time into, they're asking the distance, the horizontal distance only we need to find. Pitch is nothing but the horizontal distance covered when it makes one rotation. So if you know the time taken for one rotation, how can you find the displacement? That is the horizontal velocity. Displacement is velocity into time. So the horizontal velocity into time will give you what? The pitch. So I'm writing the formula for the pitch here. Pitch is equal to the horizontal velocity. Horizontal velocity. Velocity into the time period, the period of revolution. Period means the time taken to complete one rotation. Now, why we are taking only horizontal velocity? Because here you can see the charge is entering like this. So that velocity will have both the components. Which are the two components? It will have a horizontal component, that is V cos theta. And the vertical component, how much? V sin theta. You know that The circular motion is only due to which component? Circular motion is possible when the velocity is making an angle 90 degree with the magnetic field. So which component is making 90 degree with the magnetic field? V sin theta. That means the circular movement is due to V sin theta component only, and the horizontal movement is because of V cos theta. So here what we can write, horizontal velocity means it is V cos theta into what? The time. That's a formula for calculating pitch. But how can we find t value? For that, we can consider what? That vertical component, that is V sin theta. We already have a formula for the radius. Radius R is equal to mv by qb. mv by qb. This is the formula for what? Radius. But here, remember, it is only due to which component of velocity? Vertical. So for V, I can write V sin theta. V sin theta. Remember, students, what is theta value? It is 30. Theta is 30. What is sin 30? 1 by 2. So if I am substituting that value, I'll get m into V by 1 by 2 means I can write it as 2 qb. So mv by 2 qb is what? The radius. What is the purpose of calculating radius? Because what we need is the time period. You know that time period equation is 2 pi r by v. Distance by velocity is time period. Again, velocity means which velocity? We need to take v sin theta. What is v sin theta? It is sin theta is 1 by 2. So that 2 will go up. So we get how much? So 2 goes up means 4 pi by v. See, sin theta is 1 by 2 means this 2 also will go up. We get 4 pi by v into r. Now I am substituting r value. What is r value? It is mv by 2 qb. So I can cancel v. I can cancel 4 by 2 will become 2. So look at this. 2 pi m by what? qb. This is what the time period. See, 2 pi m by qb. Now that value you can substitute, you will get the answer. So pitch is equal to, look at this, V cos theta. What is cos 30? Root 3 by 2. Root 3 by 2. Into what? Time. Time is 2 pi m divided by qb. qb. 2 will be cancelled. So we get V. What is V value? 2 into 10 power 5. 2 into 10 power 5. Okay. Into root 3. Root 3. Into pi, 3.14. Into mass. What is a particle? Proton. Proton mass is 1.67 into 10 to the power minus 27. Charge. It is 1.6 into 10 to the power minus 19. Into the magnetic field. What is the magnetic field value? 1.5 Tesla. 1.5 Tesla. So the calculation is a bit lengthy, you can see that, but I hope the concept is very clear for you. You just do the calculations, you can see that the answer will be 7.25 into 10 to the power minus 3 meter, which is equal to 7.25 millimeter. This will be the answer. 7.25 millimeter, that is which option? C. You can check the calculation. Okay. Right. So that's the way to calculate the pitch. I hope all the questions which we discussed today, we have discussed 20 important questions NCERT line by line in this session. I hope everything is clear for you. My dear students, please practice all the questions again and again. Make sure that you are thorough with this. They can ask questions in different ways. So we should be able to reach in a position where we can answer all the questions. Okay. We come back with another topic in the next session. Thank you very much.